I want to do the next project after that one. So let me get back to my x86 or x64 based machine, and let's try the next project, which should be here at 123, I think. This was 122. All right, somewhere in this mess is 123. There we are, importing DILs. All right. So we're going to download this file, hello4. All right, there it is. I'm going to run it in a command prompt. Now, if I run it here, it's going to just launch and die, I think. So I'm going to run it in a command prompt first. That's a common mistake people make. I'm going to go here, draw an ordinary command prompt, go into downloads, and then do a directory, and see that there is something called hello4, so I can run it. All right, there's hello, I use DILs. It's really pretty much like the one we had before. It just prints a simple message. All right, so here's the source code. As you can see, there's almost nothing to it. All it does is print something. So we're going to look at the address table. If you open it in PE view, you'll see, as we saw before, dozens of Windows API calls here. See if I can shrink this a little bit. There we are. As we saw before, if you go to the bottom, you'll see the DIL name. All these kernel32.dil is the library that includes all these functions. All right, now you can understand the addresses. I don't think I'll bother doing it live. I'll just look here in the instructions. It's good enough. All right, so notice the last API here called raise exception is at this address 5954C. And has data of 5D9DA. That's the location in the file, and that's the content stored at that location. And what you can see, if you examine the data section, you can find that same thing here. Here's the contents at that location. That is the pointer. These 32 bits point to the address of that API function. All right. All right, and so if you look at the import hints, you can understand how these work. The address is at 3C, 100 bytes lower. Anyway, you can find it here. I'm not going to worry about it too much. You'll learn how to track these things down. All right, relative virtual address and so on. And the image base address we've already mentioned. It always thinks it's running at 400,000. That's what EXEs all think they're running at. If you run it in Ollie debug, you'll find it loaded at a random location. Hello, text, R data, and so on. Notice this one has more effects. Now you can stop this. So let me demonstrate this. This is where it's worth doing. So here I'm going to load it in Ollie debug. This is going to help us a lot in our malware analysis. If you run Ollie debug and you open this file called hello4, which is in the downloads folder. Okay, it runs, and if you view the memory map, you see here it is at 250,000 instead of 400,000, always at a random location. Now that's annoying, and you can fix that. There is a tool from good old Didier Stevens, one of the geniuses of Windows, wrote this tool called set DIL characteristics, and I think it's already in this machine. Let's see. Maybe not. Let me see if I've already got it in my available command prompt. Set DIL characteristics. It's not there. Okay, I guess I'll download it. The file is in my downloads folder anyway, so I'm going to go here, open in a new tab. Here we are, and zoom in a bit. And there it is. Download this file. File not downloaded, potential security risk. Very annoying. How do I override this? Allow download. Oh, good. All right. I hope that worked. Everybody keeps adding security measures, getting in my way. Okay, here's a command prompt. I'm in the downloads folder. Let's do a directory. It's there, set DIL characteristics. Okay, I just want to unzip it. It's easier to do in the GUI. I'll go to downloads, and I will right-click, extract all, and extract. Okay, and so now it creates an exe And there are some other things here, so I'll just use it in that folder. Let me check my instructions and see how I dealt with the problem with the folders here. Control W, unzip the file, and move it in the same folder. Okay, fair enough. So I'll do that. I'll go here. All I need is this exe, but I want it to be in the downloads folder where the hello4 file is, so I'll just move it there. There, now the downloads folder contains setDill characteristics and hello4, which is what I want. And now I just run it with the -D switch to modify that file. So if I do my directory now, I'll see that I have setDill characteristics and I also have hello4. Now if I run setDill characteristics, it will give me the help message, and here it tells you -D will clear dynamic base. Dynamic base is ASLR, address space layout randomization. So you can just run it with a -D on hello4, and now hello4 will no longer have dynamic base. And what that means is if I run it in Ollie and launch it again, hello4, and look at the memory. Oops, I didn't do the right one. View memory. There. Now, it loads right where it should, 400,000, 401, 440. So this is a way to make your life simpler. You can force things to load as if they were compiled without the position-independent executable, and then you know right where they are. It makes analyzing them easier. It'll help quite a bit in the projects. So that's a useful trick. And so now there's a flag defined in the import directory table. And now there's another file to download. It uses 2 dills, and you want to find the other dill. And here's another one where you have to find something in there. And this one's broken, and you have to finish it. And there's some source code here to guide you. So this gives you some clue what API calls it uses. You'll find you have to fix something about the libraries. And knowing something about which API calls it's trying to use will help you figure out what library it ought to be using. So there's a few more projects to do that just help you practice understanding PE headers and library imports. So I'll stop this.